Friends, today we are going to discuss second part of complex function or complex number. So today it is our second part of our discussion of this complex series. So let's start the discussion. Today our topic is the argument and so many properties of complex function. The first topic, argument of complex function. Argument of complex function means what? What do you mean? We have discussed little bit about the argument of complex number, but today we are going to discuss in deep detail about the argument of the complex function. Argument of complex function. So what do you mean by argument? Argument means what? Argument means angle made by the mod of that complex number with real axis. We have discussed that thing. Means if you have a complex argand plane, let me draw clearly. If we have a complex argand plane x iota y, okay, and draw a point from here, okay, at point P, and here point coordinate is x comma y, okay. Theta is the angle where this thing is making angle theta with real variable x. Here it is y. So what will be the argument? Argument will be defined in such a way that argument equals theta equals tan inverse y by x. Why tan inverse y by x? Because from the picture we can tell that x equals what? X equals r cos theta and y equals r sin theta. So argument equals what? Argument equals theta equals tan inverse y by x. So what can we say? In what we can say that argument of the complex function will be tan inverse imaginary part divided by real part. Imaginary part divided by real part. So let's discuss some important properties on argument. Important properties of argument are argument of z1 z2 equals arg z1. Let me write. Argument of z1 z2 equals arg z1 plus arg z2. Argument of z1 into z2, z1 and z2 two complex numbers. If their argument is argument of z1 into z2, then we can write it as argument of z1 plus argument of z2. Second property is argument of z1 by z2 equals argument of z1 minus argument of z2. Okay. Now let's discuss about the principal argument. What do you mean by principal argument? Principal argument of any complex number. Principal argument means if theta lies between, suppose in an open interval and it is in closed interval. Suppose theta lies between minus pi to plus pi. Here it is open interval, and here it is closed interval. Actually what it denotes? It denotes minus pi less than equals theta less than equals pi. So then theta is called as principal argument. If it is such that open interval minus pi comma pi closed interval, that means theta has range minus pi less than equals theta less than equals pi, then we can say that it is principal argument. Another important properties of arguments are argument. Let's discuss quickly from that property. Argument of z1 by z2 z3, it will be like argument of z1 minus argument of z2 minus argument of z3. because argument of z1 by z2 z3 means what? Argument of z1 minus of argument of z2 plus argument of z3. Now take the minus inside, so argument of z1 minus argument of z2 minus argument of z3. Another important property, but before discussing that, we will discuss the difference between arg z1 only argument, arg z only argument of z and principal value of argument of z. What's the difference? Actually, arg z, only small arg z, it is only valid for multi-valued function. Multi-valued function. And capital arg z means principal argument. It is valid. Principal argument. It is valid in single valued function. Single valued function. Z means here multi-valued and single valued. Both some of you are maybe some of you are in confusion that what do you mean by that? Multi-valued and single valued. It's so much thing to discuss about this. So let's discuss. Actually, what? Whenever we do, discussing that multi-valued function means, suppose when you are drawing a complex argand plane, okay, here it is p comma xy, okay, it is z, that means it is z complex number. Suppose here it is making an angle pi by 4, okay, and now if it is coming in such a way that it is making this angle, means it is, if we come from here, suppose here it is a complex number and here it is making angle pi by 4, suppose pi by 4. Now you are coming from this thing, from this point, try to understand. Now you are here, now here you are rotating in such a way that you are again coming to this complex number. That means pi by 4 plus 2 pi is added to the rotation, but you are getting the same thing, same point. Means suppose you are standing at here, okay, and here it is a complex function, okay, that's all right. Now you are making an angle pi by 4 with this thing, you are making an angle pi by 4, okay, but now you are rotating in this way, and you are coming to the same point, same line. That means you are being rotated pi by 4 plus 2 pi. Means what? I am trying to tell you that you are getting same value as in the pi by 4 and as in the pi by 4 plus 2 pi. That means what? Here pi by 4 is what? Arg of z. Similarly, means I am trying to say that suppose z equals 3 plus 2 iota. Okay. So what is the argument of this z equals 3 plus 2 iota? Arg of z, theta equals tan inverse y by x. Okay. Theta equals what? Tan inverse. Let's take an easier example for making you clear about that. Not z equals 3 plus 2 iota. Let us take z equals 1 plus iota. Okay. Z equals 1 plus iota. Yeah, it is very easier example to make you understand about the multi-valued function concept, about the argument of z concept. Now theta equals what? Theta equals tan inverse y by x. Here y coefficient is what? Means imaginary part is what? 1 and real part is 1. That means tan inverse 1 means what? Pi by 4. Okay. Now if you here argument of z is what? Pi by 4. Arg of z is pi by 4. Now if you rotate 2 pi extra, pi by 4 plus 2 pi, 10 pi by 4 plus 2 pi, you will get 1. So actually this is same, you will get same thing, you can write same thing. If you are writing argument of z tan inverse y by x, that means we can similarly get argument of z as, not principal argument, pi by 4 plus 2 pi. means we are getting the same value for rotating 2 pi as well as rotating pi by 4 as well as rotating pi by 4 plus 2 pi. That's the concept of actually multi-valued function. So that is the difference between only argument of z and principal argument of z. It is valued for multi-valued function. Multi-valued function means what? We are getting the same value for different points. Means for different argument, we are getting different values of argument of z. Multi-valued function. And here it is single valued function. So similarly, principal argument, what we can write? Principal argument is such that if range is such that, here let's draw the diagram. Here principal argument is valid for single valued function, means suppose here single valued means open interval, that value, and close interval of that value, starting from open interval and ending at close interval of that value. Suppose you are at some point theta equals 0, you are coming to this point, here it is anti-clockwise direction, 0 to pi. Similar way, if you are coming from this way, you are getting at same point, you are going to the same point, and here it is also theta equals minus pi, but here you are going theta equals minus pi, not same thing. It is actually different thing. Actually principal valued function, it is valid for only single valued function. For the time being, only know this thing, that multi-valued function will be applicable for only small arg z, and for principal argument of z, it is valid for single valued function. Means single value, means for single point you will get single value. So actually we can write it as in such a way that open interval, it's starting from open interval and it's ending on close interval. It is a principal value. So let's discuss how can we write the principal value actually. Let's draw the diagram and let's understand the value of the principal value in different quadrant. Here it is x, y, x, y, y. It is first quadrant, second quadrant, third quadrant, fourth quadrant. In the first quadrant, principal value of argument of z will be what? Theta. In the second quadrant, if theta is lying in the second quadrant, if theta is lying in the second quadrant, then argument of z will be pi minus theta. Yeah, pi minus theta. Let me write clearly. Argument of z will be pi minus theta. If theta lies in the third quadrant, then argument of z will be minus pi of theta. If theta lies in the fourth quadrant, then argument of z will be minus of theta. That's it of the principal argument of z. Principal argument of z will be theta in the first quadrant. Principal argument of z will be pi minus theta in the second quadrant. Principal argument of z will be minus of pi minus theta in the third quadrant, and it will be minus of theta in the fourth quadrant. Suppose let's discuss some problems. Suppose you are given 2 minus theta I. We are giving you two complex number 2 minus theta I minus 1 plus here minus 1 plus 7i. Okay, so here it is z1 and here it is z2. Suppose you are given that obtain the value of mod of z1 z2. So what you will do, suppose you are given this thing, z prime is defined as z prime. Let me write clearly. Z prime equals what? Z prime equals 2 minus theta I minus 1 plus 7i. Okay, 2 minus theta I minus 1 plus 7i. Here it is z1, here it is z2. Okay, so you are asking that, someone is asking you that obtain the modulus of this complex number. Then how you will do it? It is a complex number z1, it is a complex number differently at z2. Now apply the properties of the complex number. Properties of the complex number is what? Properties of the complex number is mod of z1 z2 equals what? mod of z1 itself into mod of z2. Now mod of z1 equals what? Mod of z1 is 2 minus 3i. That means what? 2 square plus 3 square. That means what? Root 13. And mod of z2 will be what? 1 square plus 7 square. That means root 50. So mod of z1, mod of z1, z2, that mod will be mod of z1 into mod of z2. So mod of z1 is root 13, mod of z2 is root 50. So we can write it as mod of z1 root 13 into 2 root 5. Okay, sorry. 2 into 25, that means 5 root 2. 5 root 2. So we can write the value of this modulus will be 5 root 26. Okay. Second question. Let's discuss second question. Second question is what? Suppose you have been given z equals lambda plus 3 plus iota root 5 minus lambda square. Okay. So what equation it will give? What is the equation of this complex number? So how we will proceed? We know what? Z equals x plus iota y. So from comparing these two equations, what we will get? We will get x equals lambda plus 3, y equals root 5 minus lambda square. Okay. Now write it. X equals what? Lambda plus 3, y equals root over 5 minus lambda square, square both side, y square equals what? 5 minus lambda square. So now, and here from here what we are getting? From here we are getting lambda equals what? X minus 3. So lambda square equals what? X minus 3 whole square. So what we can write? What we can write? The modulus of that function. So let's write the modulus of that function. We can write here that x minus 3 whole square plus y minus 0 whole square equals root 5 square. Now let me explain about this part actually. What's actually happened? What actually happened here? We have been given this thing, z equals lambda plus 3 plus iota root 5 minus lambda square. That means real part, imaginary part. So x equals, we have got that lambda plus 3. So lambda equals, we have got x minus 3. Y equals, we have got root 5 minus lambda square. On squaring both sides, we have got y square equals 5 minus lambda square. Okay. So let us write y square equals 5 minus lambda square. Y square equals 5 minus lambda square. So put the lambda equals x minus 3 here. Y square equals 5 minus x minus 3 whole square. So we can write what? We can write x minus 3 whole square plus y minus 0 whole square equals root 5 square. So we can write the equation as what? X minus 3 whole square plus x minus 3 whole square plus y minus 0 whole square equals root 5 whole square. So it is what? It is the equation of circle. Equation of circle. How? What type of circle? Here circle has center at 3, 0. So this is the equation of circle having center at 3, 0. Let's discuss another thing, another problem or another topic. Suppose we have 1 plus iota z. We have a complex number, suppose 1 plus iota z. So argument of z will be what? Argument of z will be theta. Argument of z will be theta. Sorry, z equals 1 plus iota. Yeah. Argument of z will be theta. Now what? So theta equals what? Theta equals, it will be, yeah, we have discussed a few times ago na, this problem. Yeah, sorry, I'm again discussing this problem. Theta equals pi by 4. So that is a thing. So let's discuss another thing. Let's change the topic actually, or let's discuss some principal, find a principal argument. Principal argument means, suppose we have a complex number 1 plus root 3 iota. Yeah, we have a complex number 1 plus root 3 iota is there. Now small argument of z is what? Small argument means, not small argument, sorry, capital ARZ means principal argument. Now we have to find the principal argument here. Find principal argument here. So how can we proceed? Small arg z equals, suppose we are finding principal argument of z equals 1 plus root 3 iota. So argument of z equals what? Argument of z equals tan inverse root 3 by 1. Tan inverse root 3 by 1 means pi by 3 is the argument of z. Now we have to find the principal argument of z. Principal argument of z is what? So let's discuss. Principal argument of z in which quadrant? If we have been asked that we are drawing a quadrant system x here, iota y here. So in the first quadrant, principal argument of z will be pi by 3. In the second quadrant, principal argument of z is pi minus theta, that means pi minus pi by 3, that means 2 pi by 3. In the third quadrant, it will be minus 2 pi by 3 because minus of pi minus theta. And in the fourth quadrant, it will be minus of pi by 3, minus of theta. So that's the principal argument of the z in different quadrant. That means what we have come to conclusion that in case of principal argument of z, only small argument of z you will get one value. For principal argument of z in different quadrant, similar in quadrant 1 you are getting the value theta. In quadrant 2 you are getting the value pi minus theta. In quadrant 3 you are getting the value minus of pi minus theta. In quadrant 4 you will be getting the value what? Minus of theta. Yeah. So we are going to discuss another important topic. That another important thing that you all should know, that complex function in terms of exponential. So this is a very important thing. Whenever you will discuss e to the power iota 2n pi, let me write clearly. Whenever you will write e to the power iota 2n pi, e to the power iota 2n pi, 2n is always even number. So e to the power iota 2n pi is what? Cos 2n pi. Oh, sorry. For this, before this, I have to reveal one formula nearby you so that you can understand this thing. So what is Euler's theorem actually? Euler's theorem is actually e to the power iota theta. Yeah, exponential of iota theta. It can be written as cos theta plus iota sin theta. You all know this. Hope it can be written in such way. Suppose you are writing e to the power iota 2n pi in terms of in place of 2n pi you are writing e to the power iota 2 pi. So you can write cos 2 pi plus iota sin 2 pi. Yeah, e to the power 2 iota pi means what? Cos 2 pi plus iota sin 2 pi. Cos 2 pi is what? Cos 2 pi 1. Iota sin 2 pi is what? 0. So equals 1. That means similarly in case of e to the power iota 2n pi, the value of e to the power iota 2n pi, it will be 1. Similarly, one important thing, if the coefficient of iota is here odd, e to the power iota 2n plus 1 pi, coefficient of iota will be odd, then it will be written as minus 1. Similarly, one important more thing, e to the power 4n plus 1, e to the power iota 4n plus 1 pi by 2, it can be written as I. E to the power iota 4n plus 3 pi by 2, it can be written as minus I. So this is the important thing that you should all know. Now we are going to discuss De Moivre's theorem. De Moivre's theorem. De Moivre's, sorry, wrong spelling. Please correct me if I am wrong, if I am doing wrong spelling or anything wrong. Please correct me in the comment box. De Moivre's theorem. So De Moivre's theorem is what? If you are writing cos theta plus iota sine theta whole to the power n. So it can be written as what? It can be written as cos of n theta plus iota sine n theta. Yeah. This is the de Moivre's theorem where n is integer. N is integer. So de Moivre's theorem is what? Suppose you are writing here cos theta plus iota sine theta. Okay. Here you are writing suppose what should we take? Suppose we are taking here alpha by beta. So de Moivre's theorem can be written as cos of alpha theta by beta plus iota sine alpha theta by beta. Yeah. Or in similar way we can write cos alpha theta plus iota sine alpha theta whole to the power 1 by beta. So this is the de Moivre's theorem. And in the de Moivre's theorem, another important thing in the de Moivre's theorem, that if n is integer in case of de Moivre's theorem, if n is integer in case of de Moivre's theorem, then it will be single valued function. Very important thing here. If n is integer for de Moivre's theorem, then it will be single valued function. And if n is rational number means what? Any number that can be expressed in terms of p by q. If n is rational numbers for de Moivre's theorem, then it will be multi-valued function. So this is actually the formula of de Moivre's theorem. Now another important property of complex number that I am going to discuss. Another important property, when we are taking cube root of 1, so what it will be? Oh, let me change the pen color. It would be actually 1 omega square. It's very important thing where omega is actually -1 plus minus root 3 iota by 2. So it's very important thing you should know that actually cube root, actually the topic is cube root of unity. Cube root of unity is what? When you will do cube root of 1, let me write properly. When you will do cube root of 1 will give you what? It will give you 1 omega square. Omega equals what? -12 plus minus iota root 3 by 2. Yeah. And omega square will give you what? Omega will give you what? Omega will give us -12 plus iota root 3 by 2, and omega square will give us what? -12 minus iota root 3 by 2. And the property of this cube root of unity is that 1 plus omega square equals 0. 1 into omega square equals 1. Omega cube equals 1. Omega cube whole to the power n equals 1. That's thing. If 1 omega are complex cube root of unity, actually these are the complex cube root of unity. So then suppose you have to